All right, let's talk about synclines and anticlines. What causes them? Geologists assume that all rock layers started as horizontal layers. This means that the rock layers of Columbia River Gorge used to lay flat, but now we see it like this. It was like this, and now we see it like this. So it makes you wonder, what is going on? We just heard that scientists assume that all landscapes, all the rocks were laid down horizontally. So when we see a landscape that does not look like this, but that looks more, used to look like this, but looks more now like this, it indicates that there is some compression that's taking place where we live. So since we certainly do not live in a place where it looks straight like this, as you can see out on this tour that you're on, you're seeing all sorts of hills and valleys. In fact, at this particular place, you're seeing the north side of the Columbia River tilting down towards this big, mighty river. So I'm going to draw in green. Here is the Columbia River, and we're seeing this north slope that's sloping down like this on the other side of the river. It comes up. This is called an anticline and a syncline, anticline and a syncline, which is very unique in our landscape. Actually, it's not all that unique. It's happening all up and down Oregon and Washington. Now I want to tell you why. So I met a scientist, a local geologist today, whose name is Rob McCaffrey, written backwards on this whiteboard. And he's been for the last 25 years going out to Oregon and Washington, and he has these points all over the state. And what he does every so often is he goes to it and all over Washington state. What he does is he spends many days out backpacking, hiking, sleeping in the woods, and taking measurement of these spots and seeing how they have changed. And what he's discovered is that for 25 years they have moved. And they move about a few centimeters a year. And let me show you what they look like. Basically what he's discovered is that they are moving. Each of these spots is moving in this direction that the arrows are pointing. So in a sense, Oregon is twisting up towards Washington. And what he noticed up in Washington is the points he was measuring show no movement at all. So here we have all this movement down here, and this whole plate is moving, and it's bumping up against Washington, which isn't moving at all, and so it's causing compression. So again, it's causing compression. Here's Washington staying put. Here's Oregon moving closer to Washington, and look what's happening to the landscape. So why is Oregon turning and twisting and bumping up against Washington? Well, here we have our transform boundary between North America downward and the Pacific Plate, which is moving upward at the San Andreas Fault. And what happens, what's really interesting, is what's happening right here. So as that fault's going up, it's tipping the bottom corner of this landscape of Oregon. It looks like this. Let's imagine that the Pacific Plate, which is here, the Frog and Toad Treasury Book is representing that. And the North American plate is Days with Frog and Toad is being represented by the North American plate. And here, Olivia is representing the remainder of the North American plate. So watch what happens as I move the Pacific Plate up and the North American Plate down, which is what's happening at this transform boundary at the San Andreas Fault. This is going up and that's going down. And look at what's happening to Olivia, to the North American Plate. It gets twisted and turned.